The next video will show us the relationship between a trigonometric function of tangent of four complex numbers, in this case iz, is equivalent to I times the hyperbolic function of tangent z. So let's show the proof of this using the identities for tangent and hyperbolic tangent z. We know that the tangent z is equivalent as the ratio, or is equivalent to the ratio of sine z and cosine z. We have here e to the power of iz minus e to the power of negative iz all over I times e to the power of iz plus e to the power of negative iz. Please try to review the video discussing this because this is actually the form for our tangent z. As for the hyperbolic function of tangent z, it's of course as well a ratio of the hyperbolic function of sine and cosine. Its final form is indicated as e to the power of z minus e to the power of negative z over, okay, e to the power of z plus e to the power of negative z. So we're going to show that if we're going to change the angle here into iz, that means all the z's here, 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 and here will be changed to iz, would be equivalent to this form times I. You have here I times that form. Okay, so at least we know our target. So we are going to show now the form using this proof. So allow me to start with a proof here using our left hand side, the tangent of iz. Again, we're going to change the angle here, which includes all the z's here, into iz. This will be equivalent to e to the power of I, and then our z here will become iz minus e to the power of negative I, again iz, over, you have another I factor here, e to the power of I, iz, plus e to the power of negative I, iz. Okay, so that's the form here. Again, we're changing everything into iz, all z's into iz. So what is to be done next is to simply multiply all of this. We could have one form. So this is the next part here. We will have e to the power of I squared z minus e to the power of negative I squared z. That's for the numerator. Denominator, I. Then we have here e to the power of I squared z plus e to the power of negative I squared z. Now, we all have I squareds here. Take note that if we have I equivalent to negative, square root of negative 1, I squared is actually negative 1. So we're going to substitute that to all the I squareds here. Okay? So what will happen is it will become a negative coefficient. So it will become like this. E, you have negative z because that's negative 1 in z, over, this is negative 1, but since you have a negative sign here, that will become plus, so positive e to the power of z, over, you have here I times this one here, again, e to the power of negative z plus e to the power of the negative of negative 1, so positive z. Okay, now from this point we can actually look into our target for us to be guided. Look at our target. Our denominator is a sum of the e to the power of z and e to the power of negative z. Here, it's already that one here, but just rearrange. So, we're already okay with this, except that we already have I here, and we need to cancel or probably simplify later on. But at least, a portion of our target is already provided. Similarly, here, our numerator is a difference between e to the power of z and e to the power of negative z. Okay, but here e to the power of negative c is the first term or the minuend, and the subtrahend is the positive. So what we can do here is rearrange them just like what we did in proving the relationship between the sine, trigonometric and hyperbolic function. So if you would like to review that, you can also review that one here, there, a specific video for that. Let me rearrange this. I will have negative e to the power of z plus e to the power of negative z, so that I could meet this target here. But since it's minus, and this time it's plus, so we're going to factor negative later on. So allow me to continue with my denominator, e to the power of, and then, by the way, on my denominator, I'm also going to rearrange it in this manner, okay? So that, and I can do that because it's plus, that's no problem, e to the power of z plus e to the power of negative z. Now, I mentioned I'm going to factor -1 on our numerator because my target is negative here. So that this will become negative. As I factor that out, I have positive e to the power of z minus e to the power of negative z, which fits this idea now. So we factored -1 for that. As for the denominator, okay, so you will have I times e to the power of z plus e to the power of negative z. Again, this is already okay. But what we need to do here is to simplify these two coefficients, because this remaining here already met the criteria for our target. Okay? But we just need to look for a possibility of factor of I. And that is where this will come in at this form. Because we know that -1 is I squared. And we have here -1 in our numerator. Okay? Specifically this one here. So we can write our numerator into this form. I squared e to the power of z minus e to the power of negative z all over I as it is e to the power of z plus e to the power of negative z. With that, we can now cancel one I, and we have here a factor of I with this already equivalent to the hyperbolic tangent of z. So we have here the final form. We started with the tangent iz, this one here, which yielded a factor of I times the equivalent form of this, already provided as this one here. So we have the hyperbolic function of tangent z. This is the proof that these two are actually equivalent, or they form an identity. Once we change the angle into iz, we're able to come up with a certain factor of I with the hyperbolic function of tangent z. Okay? That is the proof for this video. Thank you very much for watching.